All right, so we want to do 10.3 number 65, which says simplify rationalizing the bottom. I just told you that this wasn't a thing we were going to talk about. So this one is more useful than the other kind. The other kind where I just have a root on the bottom and I turn it into not a root on the bottom, I really trade that thing to the top. That's not so useful. Knowing how to do this is useful for some calc concepts, so we should maybe figure this one out. All right, so I want to get rid of this little rooty thing in the bottom, right? This is a lot like when we got rid of i's in the bottom. You guys remember doing that? You remember how we got rid of i's in the bottom? Yeah, we multiplied top and bottom by a kind of a thing that felt a little bit like a negative but wasn't quite. Do you remember the name of it? Starts with a C.
Coefficient.
No.
Conjugate.
Conjugate.
Yeah.
Yeah, so we're going to do that same trick here. Here we're going to think, all right, this guy's got units of 1s on it. This guy's got units of root 7s on it. So let's see. If I multiply the 1 by a number, right, I'll be fine. I'll be in kind of integer land, which is where I want to be. What do I need to multiply this guy by to get into integer land? Yeah, root 7 at least, right?
Yeah.
You guys see that? And then I want the cross terms to cancel. So I should multiply by the conjugate of this thing. That's 1 minus root 7.
Oh.
But now I changed things, right? So what do I need to do? Yeah, we got to multiply on the top 2 by this thing. Okay, and we get, well, we pay a price, right? We get 3 times something horrible on the top. 1 minus root 7. But on the bottom, our life gets easier. On the bottom, what do we get?
1.
No, I should throw some parentheses in here, right? I get 1.
Minus square root of 49.
Yeah, let me do it with the cross terms too. So there's, FOIL goes outside,
Right.
right? So I've got minus root 7s. Then the insides are plus root 7s. And the lasts are
Minus square root of 49.
minus square root of 49.
You got me all confused, man. That's what I was saying, and then you're like, you give me that look, and I feel stupid, so I stopped saying it.
Don't feel stupid. Sometimes it's just me looking at you being like, is that reasonable?
Gotcha.
Not is that right?
Yeah, no, sometimes I'm just trying to ascertain whether you're saying the thing I want you to say in a different way or not. Take some interpretive moments. All right, let's see. So I got, the cross terms canceled, right? That's really that's kind of what this conjugate was good for. You might want to put that in your bag of tricks for, I want to get rid of something that looks like 1 plus root stuff. I can multiply it by something that looks like 1 minus root of stuff. And then at least it'll go into the other spot, right? Does that make sense? I kind of traded this rooty business from the bottom to the top. Actually, I haven't finished trading it, right? What more simplification can I do here?
Root 49.
Root 49 is 7. So I've got 3 times 1 minus root 7 over
6. Negative 6.
1 minus 7 is negative 6. Now what?
Can you distribute the cancel? Oh, wait.
We could distribute the 3, or
that would
we could cancel it. So if I cancel the 3, what am I left with on the bottom? 2. So I get 1 minus root 7 over negative 2. Is this simplified fully?
Yes. As far as we want to go.
Yeah, what more could I do with this?
Get the decimal for root 7.
Don't, no.
Oh.
We could get an approximately equals to, right? Depending on the kind of problem we were doing, we might be interested in that. But what other simplification can I make with an equal sign?
Take the conjugate of that.
Okay, so if you multiply by the conjugate of the top and bottom, you're going to go back to the beginning.
No, I mean like flip the signs.
Oh, that's a much better idea. So I've got this minus on the bottom, right? I could move that to the top without paying a penalty, right? So I might multiply top and bottom by -1. That'll get me root 7 minus 1 over 2. Cool. Can anybody give me an approximation for this with ballparkedness without going to a calculator? Is ballpark this?
Goes to 1.
It's about
1.7.
It's about 1.
Root 7's a little smaller than 3, right?
It's a little bit less.
So I might do like 3 minus, like a little smaller than 3, minus 1 over 2. A little smaller than 3 minus 1 is going to be,
A little smaller than 2.
so I've got like 2 minus over 2, so this is,
A little bit smaller than 1.
yeah. This is like kind of crummy notation, right? This is not really math that I'm doing, it's just kind of ballparking, right? So I might say, oh, well, this guy, that might be a little bit smaller than 1. Cool? So depending on what I'm using this for, that ballparking is a nice way to estimate whether you got the right answer or not. Right? Like if this is supposed to be the number of penguins in a flock, a little bit smaller than 1 is probably not going to cut it, right? Does that kind of make sense?
But I feel like 0.9 penguins isn't going to cut it.
Yeah, not going to cut it either. Well, at least you're going to have to cut the penguin to get it.
Right, that's true.
That's not nice.